talk about how engineering organisms may be able to create a stable biosphere on practically any world. The organisms creating a layer in the upper atmosphere that helps prevent gases from escaping would have to have 3 phases of life. That starts its life cycle in the water. It would also create large amounts of polyunsaturated fats. Then would start splitting the water molecules. It would store the hydrogen and evacuate as a gas. Eventually the organisms would float into the air. The more water it processed into hydrogen, the higher it would get in the atmosphere. The organism would need an enzyme that's activated by UV light to start consuming the hydrogen, hydrogenating the polyunsaturated fats it stored earlier. The consumption of the hydrogen causes the organism to descend. Once it gets low enough in the atmosphere, the organism would start scavenging oxygen and burning it with the hydrogen left in its vacuole, weighing it down even more. Eventually, it would settle on the ground. The organism would then divide into 2 cells, completing its life cycle. Mercury receives 5 to 10 times the solar energy in a given area than the Earth and the Moon do. However, I think it could still be terraformed anyway. Mercury is dense, which gives it gravity that almost exactly matches that of the planet Mars. However, using a method to retain its atmosphere, similar to the one I described in my video about the Moon, would still need to be used. The main modifications that would be needed to make floating organisms sustain Mercury's atmosphere and temperature would be to make them photosynthesize nearly the whole entire light spectrum coming from the sun. This would create a sunshade over the entire planet. The organism's photosynthetic rate could be fine-tuned using temperature-dependent enzymes, so they absorb less light when they're cooler and more light when they're hotter, so they would act like a thermostat, keeping the atmosphere in a desirable temperature range. Another important aspect is that they would have to be completely transparent to infrared light, otherwise the heat from the sun and the organisms themselves would get trapped, causing a runaway greenhouse effect. If we can terraform temperate worlds like the Moon and hot worlds like Mercury, why not see if we can terraform cold worlds like the moons of Jupiter and Saturn? The advantage of the outer moons of the gas giants is that, unlike the Moon and Mercury, they already have the needed volatiles to terraform them, mostly in the form of water ice. But what are the cons? Well, one issue is that many of the worlds sit in the radiation belts of their parent planet. Even with worlds where radiation is not an issue, there is a much bigger problem. They're beyond what's called the sun's snow line. Beyond the snow line, water freezes. In fact, if you terraform them, almost all the worlds beyond the snow line would have oceans so deep they'd make the deepest oceans on Earth look like springtime puddles. Because of their deep oceans, they would have no solid surface. But ice is very useful since we can easily melt it, and all you have to do to make it harden is let it cool off. So, although it may be possible, I would argue that the outer moons in our solar system, for the most part, are better left unterraformed, or at least not wholly terraformed. I've covered several of the more oddball worlds like the Moon and Mercury. However, I think terraforming Venus would be much harder to do. High up in its atmosphere, it has some of the best conditions. Or to make the place inhabitable on its surface, you need to remove a lot of atmosphere. Venus's atmosphere is 96% carbon dioxide. If there were some way to import a lot of hydrogen, then it may be possible to react it with the carbon dioxide, making carbon and water. If you converted all of the carbon dioxide, then Venus would have an ocean covering around 80% of its surface area. The absolute biggest issue would be importing enough hydrogen. But let's assume you could get the needed hydrogen. At that point, you could use the organisms I described in my previous terraforming videos to make water, oxygen, and carbon for its cellular structures. Due to the thick atmosphere, this would still probably take hundreds of thousands to millions of years. In light of that, in spite of the fact that Venus has one of the most hospitable environments to Earth life in its upper atmosphere, it's probably the most difficult world in the inner solar system to terraform, to have livable conditions on its surface. 256 is 100, or looks like it, in hexadecimal, and 16 looks like 10. Why do computers use hexadecimal instead of base 10? Digital computers have pretty much always consisted of electrical logic gates known as transistors, or, in the very early computers, vacuum tubes. Like a light switch, the gates can either be on or off. It's the on-off nature of the gates that give computers their base numbering system, which is binary. It would be extremely difficult to work with a program for a CPU that could only handle one digit of binary, so they made small memory banks in the CPU called registers to hold a string of binary bits. Conveniently, numbers that are 8 or 4 bits long can easily be represented if you use the number base known as hexadecimal. In base 16, the numbers above the 9 are replaced with the letters at the beginning of the alphabet. This means you can represent an 8-bit number with 2 characters on the screen. At this point, you might be able to see why they didn't go with base 10, because there was no way to chop up the register into decimal-sized pieces.